This is a limit proof. The limit that I'm looking at is for the function sine of theta over theta. Here's a graph of y equals sine theta over theta. The numerator is sine theta, which is an odd function. The denominator is theta, which is an odd function. Odd functions map onto themselves by rotation, 180 degrees about the origin. When we divide an odd function by an odd function, we get an even function. Even functions map onto each other by reflection about the y-axis. And we can clearly see that we're looking at an even function there. And as x or theta takes the value 0, sine of theta on theta clearly passes through the point 1. So 0, 1 is a point on this function. We're going to try and prove that limit. So if we construct a unit circle here, that is a circle with radius 1, and we bring in this blue radial line from the origin, the length of the blue radial line from the origin to the circumference is clearly 1. Now that makes an angle of theta with the positive x-axis. So by dropping down from the point where the blue radial line hits the circumference, dropping down another blue line perpendicular to the x-axis, what's the length of that vertical line? Sine of theta is equal to the opposite over the hypotenuse. Sine of theta is the opposite side over 1. So that opposite side is sine theta. If we drop down a green line from that same point on the circumference down to the positive x-axis where it intersects with the circumference of the circle, we get a second smaller triangle. Then beyond that, we have the sector of the circle that is made up by that slice with the angle theta. If we construct a larger triangle that goes outside the circle by dropping down a blue line from the blue radial line down to the positive x-axis where it intersects with the circumference of the circle, what is the length of that? We know that the base of that triangle, that is equal to 1. So the opposite side over the adjacent side is equal to opposite over 1. Opposite over adjacent is tangent. So tangent of that angle is the length of that side. We have three areas we can work out. The area of that inner triangle, along with the little green-sided triangle, half times 1 times height. The vertical height or the perpendicular height is sine theta. That gives us sine theta on 2. Now what's the area of the segment? The area of the segment is simply theta on 2 pi times pi r squared. That simplifies to theta over 2. The pi's cancel and r is 1. So that gives us theta on 2. Now what's the area of the larger triangle? Well, again, that's half base times height, which is half times 1 times the perpendicular height, which is tan theta. So tan theta on 2. From the last slide, we had three areas. The first one was sine theta over 2. The second one was theta over 2. And the third one was tan theta over 2. We know that sine theta over 2 is less than or equal to theta over 2, which is less than or equal to tan theta over 2. First step, multiply through by 2. So we get sine theta is less than or equal to theta, which is less than or equal to tan theta. Sine theta is less than or equal to theta is less than or equal to tan theta. Now let's divide through by sine theta. That gives us 1 is less than or equal to theta over sine theta, which is less than or equal to 1 over cos theta, because tan theta is sine theta over cos theta. So dividing by sine gives us 1 over cos theta. Let's switch that inequality around. So we'll take the right-hand term and put it on the left, and the left-hand term put it on the right. So that means we're effectively reading that inequality backwards now. So the inequality signs change. So we have 1 over cos theta is greater than or equal to theta over sine theta, which is greater than or equal to 1. Now, let's take reciprocals of those expressions, which will turn the inequalities back around again. So 1 over cos theta becomes cos theta. Theta over sine theta becomes sine theta over theta, and 1 stays as 1. So we have cos theta less than or equal to sine theta over theta, less than or equal to 1. From the previous slide, we got cos theta less than or equal to sine theta over theta, which is less than or equal to 1. Now recall, we're looking for the limit value of sine theta over theta as theta tends to 0. By the squeeze theorem, cos of theta tends to 1 as theta tends to 0. So that left-hand expression tends to 1, but the right-hand expression is 1, and it's constant. So we have two things which take the same limit value. Therefore, sine of theta over theta, which is greater than or equal to cos theta, and less than or equal to 1, must take the value 1, as theta tends to 0.